Oh yeah, but look at the like like my sense of humor is just like not gonna blow up on TikTok because nobody understands it.
Yeah, dude. But when I saw this one, the one recently here in New York, this song, like, I've never seen on TikTok, so I made a TikTok to the song just so I could keep it.
You realize you can save it,
You
right?
can save sounds and stuff. Really?
Yeah, click on the little disc thing. At the bottom right.
Oh, save video?
No. Look at the little spinning disc.
Oh,
Now go to the top
Add
where it says save
favorites?
video. Yeah.
Oh. Put something over there. Yeah, this one confused me after a while.
Oh yeah, no, because Luke's cat's name Leo, Leonard, and we were just scrolling through. I was scrolling through old videos in my saved or my what is it called? My memories. And I was like, oh, like.
Dude, this one was hilarious. I showed it to so many people. I thought it was so funny.
Yeah.
Okay.
I thought that one was gonna blow up.
Are you guys ready?
Hey, what is it? What is it?
This is Exponential Equations. It has today's date on it.
Oh. Apparently I have a 37%. So apparently I did do stuff.
If you want me to clear your attempts, I can.
I think I'll be okay. Yeah.
So is this exponential exponents? Any equations?
Yeah, it has today's date on it.
Well, on the first one, I've half of it right somehow. And I believe I still have attempts.
I signed this one earlier, and then I kept pushing it back.
Is it the same like formula as the last one?
Some of them are like the previous homeworks. Some of them are a little different.
Okay.
This one is like the last homework, the last 5 questions on it.
Oh, okay.
So the equation on the board to the right, where you put in, do you see on the chalkboard?
On the far right?
Yeah, by
Okay.
percentage. You would take P naught as your starting population. You'd multiply by 1 plus whatever the rate of growth is, and then raise that to the number of years. So in this example that I have on the board, or on the screen, we have a 5% growth rate. So my growth factor would be 1 plus 0.05, so 1.05. That's for 5%. The time, you see that we go from 2000 to 2008. So in this one, I'll leave it as a variable. So I'll just put the starting population times 1.05. That's 5% above 100%. And then I leave t as a variable. And then in the second part, they just want to know when you plug in 8 for t, what does this come out to be? They want you to round down, I believe.
Really?
Now this is interesting. Because I got 3 out of 4 of the right answers, and that's somehow I got that.
Did you get number 1?
What
Okay.
does the T stand for?
Time, the number of years.
Oh,
So because it goes from 2000 to 2008 on mine, I plug in 8 for t.
How do we plug in to get the bottom?
I mean, you can literally just plug in. Oops, I didn't need to do that. Accidentally pressed enter. And I think it'll take that. So it accepts that. So you really don't even have to compute what the number is. You can just plug in the variable.
Yes. It's the worst thing I've ever seen.
Yep. The next one is compound interest.
All the time.
that's how it is.
I got the
And it still
answer
sounds
right,
really good, Mr. Chuck.
but
And
That would be
they never
clean.
starts on
For number one?
yeah.
No way.
Just your starting amount.
It's like, it's
What's your
on
percent?
SoundCloud.
Quiet, please.
1.0.
What'd you do, 1.8?
Yeah. 0.0.
And then it goes into New York.
You have 8%.
Yeah.
It's so good.
Yeah, 1.08 raised to the
I
T.
would have shown she hates it, but.
Put your starting population.
I just want to go to New York. I mean, like, pretty
I
much
wanna be
on
like
that. You got the mentality down. Huh?
We're good.
Makes no sense.
Yeah.
You should go to this thing. You know what
The PRPO.
Yeah. You can go on there and there's like really good people. You can get for $40 a night.
Really?
And they're so nice.
Mm.
I'll try to
So put the starting population 20,000, 1.08 to the 8th power.
No, put to the T. That
Oh,
one
it's
wants it
just-
as a variable.
Oh, okay.
So that's for any given number of years, T, you can figure it out. Then the second one, they want you to plug in 8. Or is 8 the number here for you?
Yeah.
Okay, yeah. All right. All right, number 2 is a compound interest. So P here, that should be your starting principal, right?
2,000.
For me, it'd be 6,000. Your annual rate would be, for me, it's 2.1, so I put 0.021. And then N, it says it compounds quarterly, so what would be my N? 4, yeah, so I'd put in 4 for N. And they want you to plug it in. I don't know if it'll, I think, no, it wants a number here. So you're gonna have to actually plug in your values. For me, it should come out to that much, 2 decimals for cents. You're not gonna go more precise than cents.
Will you keep T the same?
T, you'll plug in 8 years, because for part B, it says
Oh,
how much money we'll have in the account in 8 years. So for me, I'd put 8.
And there's like cheap from New York.
Yeah.
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 Wait, so like,
I didn't know.
which numbers do we plug into where? Obviously P. Oh, that's it.
Plug P in for P.
I just
R.
realized it's labeled.
NT.
What's that?
The NT. What do you call it?
4, for me, it'd be 4 for N and 8 for T. So I'd put 4 times 8 up there. You might want to use parentheses around the exponent to make sure that
Wait, you
8
say
times.
8?
For me, it's 8, yeah.
So it says round to the nearest penny,
So yeah.
and I got this answer.
What's T?
What's what?
It's
Let me put it-
0.28, but I rounded that up to 3 because
Okay, so 0.057 divided by 4 plus 1. Raise that to the 4 times 7 times 2,000?
Yeah.
2972. You got to round up. It's 29.
oh, but would it be 3.9
No,
because
29.
8?
No,
Oh, okay.
only do one of them.
Okay.
The last one. So you didn't get that? So you put it in. I'd start with your R. So that is
0.041.
so then divide by 4 plus 1. Now you got the parentheses figured out. raise that to the, and then in parentheses, I'll do 4 times 7. Now times, what's your starting amount? 5,000? So 6652.40. Is that okay for everybody? Three is another one like number 1. Oh, no, it's not. So this one's a little different. I haven't gone over continuous interest. So just do what they do here, okay? E is a special number on your calculator. Above your natural log, that's like the third from the top on the left column, depending on your calculator. Or actually, you don't have to, you can just type it. So here I'm going to put my starting population, 2,500, 1,000. Then you can just type E, and then raise that to your rate. So 4% would be 0.04 times the time. We haven't really gone over continuous growth yet, but just raise the rate, put it on E. E is a special number. It's about 2.71. It's kind of like pi. It stands for a particular decimal.
So times E and then to
Yeah.
power of 3%.
The rate, don't add 1 to it, just put the rate, and then times T. And the next one, plug in, just instead of T, you can put in, so that should take that. And if I did the same thing down here, I just have to put in times 8. And it should be okay. Yeah, it'll accept that. Are we okay with that one? What was that?
1 second.
Okay. For question 4, does anybody know what power? That's a power of 5 on the right. What power of 5 is that? 625? What power of 5 is 625? 5 to the what makes 625?
25?
Not 25.
Third.
Not third, that makes 125.
Oh God. Why is it 30 now?
This is actually 5 times 5 times 5 times 5. This is 5 to the 4th, okay? So let me write out just to kind of explain how this works. Your 1/5 to the n is equal to 625 for this one. So one thing to note is we can distribute the n onto both of these, and you get 1 over 1n to the 5n. Now 1 to any power, 1 times 1 times 1, whatever it is, it's going to be 1. And then this is 5 to the n still. Because any power of 1 is 1. Now, this thing on the right is actually 5 to the 4th. Because 625 is 25 times 25, so it's 5 squared twice. So that's 5 to the 4th. Now, this isn't quite the same on the left and right. Now remember that I can always move a power up or down in a fraction by flipping the sign of the exponent. So I can turn this into 5 to the minus n is equal to 5 to the 4th. So I just moved it with the negative sign, up or down. You can do that if you remember from a previous homework. Now, if I have 5 to something equals 5 to something, these somethings have to be the same in order for these two, for the left-hand side and the right-hand side to be the same. So I can make a new equation from this that minus n has to be equal to 4, or n is equal to negative 4. So that's what I would do for that one. So you can do those. You can do that one like that for number 4. Think of this as 5 to the minus n. This is 5 to the 4th. So minus n has to equal 4. So I'd put minus 4 here. Does that make any sense?
No.
Give me one of your sets of numbers then.
I got 1 over 10. And then n or whatever is equals 10,000.
Okay, so I've got 1, 2, 3, 4 zeros here. So that is 10 to the 4th. I have 1 over 10 to the n. I'm going to move that up, and I'm going to think of it as 10 to the minus n. And once again, I get that minus n has to equal 4. So n is equal to 4.
This is wrong.
Are you sure it's 10,000?
Yeah.
That must be right.
Yeah, it's 10,000.
Wanna look?
Let me see it. Four zeros, right? Or 5 zeros? 4 zeros. Yeah, it should be 4. Let me look up your thing.
Would be negative 4?
Yes, negative 4. Is that what you put?
Nope.
Yeah, you just were missing the minus.
Oh, that's right.
Because minus n is equal to 4, so n has to be equal to negative 4.
Oh, no, that's the same question.
Is that okay?
That's next.
Okay. All right, so this one is kind of like the top equation on the board for exponential growth. You have your starting population, you have the factors that you grow by. Actually, it's more like the one underneath it, the exponential decay, because this is half-life. So you're losing half of your quantity every so often. So it's actually like the exponential decay one, where it has the initial population times 1 over the factor raised to the t over how long it takes to halve. So for me, my starting amount is 400 milligrams. My fraction is going to be 1/2 because they're talking about the half-life. So how long does it take for you to have a half of what you started with? So we'd go from 400 to 200 in 1,590 years. So 1590 is the half-life. So I'm going to go to that equation. The population at some later time is the starting population times 1 over the factor times the years divided by the time it takes to change by that factor. So I'm going to have 400 milligrams to start with. The factor is going to be 2 because I'm halving. I'm going to the half-life. And that happens every 1,590 years. So this is my formula.
So you plug in.
Yeah, I'm going to leave it. Well, let me see what they say. They say after 3,000 years. So for me, 3,000 will be plugged in for T. You can take like 0.5, raise it to the, in parentheses, 3,000 divided by 1590. I get about like 0.27 something. Multiply that by 400, and I get approximately 108.163. Is that okay? So it's half-life, so we're going to put 1/2 in here. The time it takes to lose half its value is 1590. That's like from carbon dating. And then your starting amount was 400. Then they asked us how much would be left after 3,000 years. So I plug in 3,000 for T.
What do we put in the T above 1590?
My question asked how much would you have after 3,000 years? So whatever it asks you.
Get it?
One question, so
I'm on 5. Still up with this.
Is that okay?
We'll go with it.
What's that?
So we'll go with it.
It's not working on my calculator. I'm sure I'm just putting it in wrong, but it keeps saying error.
That's what mine says.
This thing will take functions, so you could probably just put in 4,000. 1 over 2 raised to the 3,000 over 1590. Will it not take that?
Oh, it did take that.
Nice. Easy? All right, I'll do this one and the thing. Make sure I did that right. Yep. Okay, we almost have powers of 2. On the left, I have 1/2 though. So the first thing I'm going to do is make this the reciprocal on the left. I don't want 1/2, I want 2. The way I do that is by introducing a negative. Let me actually do colors, I guess. So I can introduce a negative onto the exponent on the left, and that allows me to use the reciprocal instead of the fraction on the left. So instead of 1/2, I'm going to write it as 2 to the minus x minus 6. I'm distributing that negative. So I flip the signs on the exponent, and that allows me to write not 1/2, but 2 on the left. And then the right-hand side will be the same. Now I see that I've got 2 to this has to equal 2 to this, which means those two things have to be the same. So minus x minus 6 has to equal 2x minus 3. There's your new equation. Now you just have to solve for x. So I'll add x to both sides. I get 3x, and I'll add 3 to both sides. Equals minus 3 divided by 3. I got x is equal to minus 1 in my case. So what I did was I flipped the sign on the exponent to make this not 1/2 but 2 instead. And then I equated the exponents to make a new equation. And then I just solve for x.
Can you go back to your initial problem?
It's what's in red here. It was 1/2 to the x plus 6 equals 2 to the x, 2x minus 3. Oh, let me do attendance.
What?
Carly,
And Molly?
yes.
That's it?
Yes.
Okay, thank you.
Yep.
Can I help with mine? Or
Okay, yeah.
are we only halfway down this one?
What's that?
Is that the answer to the,
To the one I have, yeah.
okay. Mine is, we do mine or?
Yeah.
Okay. To the, and then n plus 7 is then equals 5 to the 7n minus 1.
Okay. So we're going to make the left a power of 5. And to bring the 5 up, you have to flip the signs on the exponent. So minus n minus 7 equals the right-hand side. In order for that to be true, the exponents have to be the same on both sides. So then just solve for n. Add n to both sides, you get 8n. Add 1 to both sides, you get minus 6. N would be minus 3/4.
Yes.
Does that make sense?
Yes.
Good. All right. 7. They're talking about the doubling period. So that's going to be like the equation at the top of the board. Your factor is 2. And it takes 15 minutes Um, all right, so this one we got to find the initial. So we're missing the initial population this time. So after 110 minutes, we can, yeah, after 110 minutes, I wonder if I can, let's see, I do that. Well, I don't really want to do that, I guess. Do you guys know the snippet tool? Oh my gosh. Why is that not a keyboard shortcut? All right on this? Yeah, good, okay. Not bad. Okay, so we have a doubling period, so the population after some time is equal to the initial population times the factor raised to the time divided by the time it takes to increase by that factor. So I don't know the initial population. I know the final population will be 70,000. I don't know P naught. I do know that we're talking about doubling periods, so this will be a 2 for F. And the time was 110 minutes, but it takes 15 minutes to double. So I just plug in all those things. And then I want to solve for P naught. So I'm going to figure out what this thing is here on the right, and then I'm going to divide 70,000 by that.
What are we plugging for? Is that last one the second part?
What's that?
The last thing you wrote, is that the second part of the question?
This is the first answer. So my initial population is about, for me, 434 point. I'm going to do lots of decimals just to be safe. That's all the decimals that I have. They probably want us to cut it shorter, but you want to round at the end. So make it as long as you can until the very end, and then you want to round it at the very end. So that would be my answer for the first part. I'll try that. Yeah, that should work. I got half of it. Then they want to know, so this is what I'm going to use for P naught. Find the size of the bacterial population after 3 hours. So I'm going to start this again. I'm going to reuse this formula. This time I want to find what it is after 3 hours. My starting amount is 434.0549751. My doubling period, it happens every 15 minutes. This time I'm plugging in 3. Did they say 3 hours? I think they did. So that means it's 180 minutes. Because this is in minutes here, 15 minutes. So if they said 3 hours, I need to do 60 times 3 for minutes. That's 180 minutes. So if I plug this in, I get that the population should be approximately that. So I'll plug that in, see if I get it right. Yep. So you just have to use those equations up there and plug in the correct spot.
What if yours was like 5 hours?
What's that?
What if yours was 3 hours? What if it was 5 hours?
So 60 times 5 would be 300 minutes.
That's
So 60 times 4 would be 240 minutes.
So you put that over top of 15 instead of.
Whatever your numbers of minutes are that it takes to.
Why don't even get the first part?
Did you do like this?
No.
Oops, not this. What's your question then?
Evidence percentage of the population's 50,000.
I'll just read it.
Double period of bacterial population is 15 minutes. At time t equals 110 minutes. Bacterial population 50,000.
50,000. All right, so P naught would be the 50,000 divided by this number here. So make sure that when you put it in, you're going to do 50,000 divided by, well, you can do 2 raised to the, use parentheses, and that should give it to you. I get about 310.039268. That's for the first part. And then what do they ask you?
Find the size of the bacterial population after 4 hours.
So 4 hours would be 240 minutes. So the starting population is this, we found. It doubles in every 15 minutes, and you have waited 240 minutes. So you want to put this number times 2 to the, I'd put these in parentheses. I get 7. Got it? All right. Okay. They give us the initial amount. They give us a doubling time, so our effect will be 2. And the time it takes is 30 minutes. So let's see if I can do that snip tool thing again. All right, so the population to T will be 2,500 times 2 raised to the T over 30 minutes. So for the first one, I'm going to do in 20 minutes. Zeros can cancel. That should be about 3,968 and a half. Actually get this.
You put 20 over 30.
Yeah, 10, you can cancel 10 from top and bottom, so it could just be 2 over 3. But 20 over 30 should give you the same. And then in 7 hours, that's 420 minutes. Zeros can cancel. That's I think 14. We got 40960000. So almost 41 million.
You go over mine.
Yeah.
This is culturally, it initially contains 2,500 bacteria
Yeah.
and doubles every half hour. Find the size of the bacterial population after 40 minutes.
40 minutes. We put 40 in there. That should be it. So 2,500 times 2 raised to the 40 over 30. You get 6299.605249.
And it says after 5 hours.
So you would do so 5 hours is 300 minutes. So the 3's canceled. That's 2 to the 10. Because the 3 and the 30 cancel to make 10. So that's actually, I know that what that is. That's a 5. Did I take it?
I want to do mine because I messed up.
What's yours?
So I got, that's 2,000 for bacteria doubles every half an hour. And find the size of the population after 20.
Just put a 2 up, 20 up here. What'd you get?
I don't know how to put it in the calculator.
I'll see what you get so I can see if you're doing it, entering it wrong. Use parentheses. That's your problem. Put parentheses around these so that otherwise, if you do it like this, it'll just raise 2 to the 20.
That's not right.
No, it's not. So if you do this, parentheses around the 20 divided by 30, you should get the right answer. Got it? Then what's the next part?
Size of the bacterial population after 4 hours.
So 4 hours, where there's 60 minutes per hour, that's 240. Replace 20 with 240. Otherwise, everything else is the same. Got it? All right, 9 and 10 are very similar, but one goes down and one goes up. So you're going to take your starting amount. Because it depreciates at a rate of 7%, you're not going to do 1 plus 0.07. You're going to do 1 minus 0.07 to show that it goes down. So you're actually going to have a 0.93 as your percentage, because you're going to drop to 93% every so often. That's after 15 years. So 25,000 times 1 minus 0.07. Did they say 15 years? So I'd do this. Let me just make sure it's set 15. Yeah, okay. So I got 8,417.52. So I lost a lot of my value.
Excuse me.
All right, that's about time. The next one was it increases. So you use 1.07, you'd add. Everything else is the same. That should be the same as the growth. Most of those are the same except for 12. Yeah,
So we just do number, 10, just like we did number 9, but we just.
yeah, the rest of these are like the previous ones. 12's a little different. If you just divide by 3 on both sides, you'll get 10 to the x equals 1,000. That's 10 to the third, so x has to be 3 in that case. So just divide it first and then figure out what power of 10 that is. The other questions should be like previous questions, so I'll post this video so you guys can
Divide by 10?
divide by 3, and then I get powers of 10. I've got the video for this homework posted on from the last section of Algebra 2. I'll post this one too, so you'll have 2 videos to look at. All right, have a good day, you guys.
You too.